Assalamu alaikum. Let's start our experiment number 3. So in this experiment, we are going to study the convolutional encoding and Viterbi convolutional decoding algorithm. So in this experiment, for the simulation, we are going to use the MATLAB and Simulink for our simulation purpose. So this simulation part we'll see in the lab, but before starting the simulation part, we are going to see the basic theory of this convolutional encoding and Viterbi convolutional decoding algorithm. So let's start the theory part first, then we'll see the simulation part. Okay, so in the experiment number 3, what we're going to see is basically, first of all, there will be convolutional encoding discussion, then there will be state diagram representation, and last of all, we'll see the trellis diagram. Okay, as you can see in this block, there is a block shown here. This whole block, this is the block for the transceiver block. That means there will be a receiving side and also the sending side. So first of all, you'll see there's an information source given. So in the information source, this is a sequence of M1, M2 up to MI, which is our message bit. So this is the message bit that we are to pass through this block. And after the message bit is passing, there is a convolutional encoding block. Then after convolutional encoding, the message bit, it will be converted into some code word sequence. So this code word sequence, it consists of U1, U2 up to UI. And this code word sequence, it is the function of our input sequence. That means this U1, U2, and UI, they are dependent on this M value. That means our message bit that we are want to send from the input side. Then comes our modulator. This will modulate our code word sequence and make some waveform named Si of t. This waveform, it will go additive white Gaussian noise channel. And after passing through this channel, again we'll demodulate the signal. Then we'll get the demodulated output Z1, Z2 up to Zi. Then this output, it will be fed to our convolutional decoder block. And then after decoding, we'll get back our original message sequence that we have sent from the input side. So this is the whole block. But in this block, the part that we're interested in is our convolutional encoder and convolutional decoder. And these two parts, it will be discussed now in this lecture. So what this convolutional encoder do, it mainly take the message sequence or input sequence that we are talking about M, and after encoding, it will give us some some code word sequence U. So the message bit, it can be binary like 101, and then after convolutional encoding, we'll get some code word based on the binary symbols. Okay. So this code word sequence, it is nothing but the binary code symbol that we are talking about. Okay, so if I go to the next page, so here, this is our convolutional encoder with constant length k and rate k by n. So this is a diagram of our convolutional encoder that is shown here. So in this diagram, there are 4 main parts that represents. So first part is our input sequence or M. So I've already talked about this. That means this input sequence is nothing but the message bit that we want to send. So this input message bit M, it is consist of M1, M2 up to MI. That means we can say if I have a binary number, we can say let's say 101011, something like that binary input sequence that we want to send in the input side to our convolutional encoding part. So next comes this K into K stage shift register. So what is this thing? So let's write this down. This small k and this larger k. So this small k, it represents how many bits will shift, at a time. Okay. So this small k represents how many bits will shift at a time. So let's say we have a block like this. And if I give input a message bit, let's say a bit 1 of our message, then it will go to the first block, right? Then what will happen? It will, from this first block, it will go to the next block, and then in the next block, and then in the next block. So what is the sequence that it is following? So it is following like 1 bit at a time, right? So it is shifting 1 bit at a time. So for this case, we are having k equal to 1. That means 1 bit is shifting at a time, only 1 bit is shifting. Okay. So now if k becomes 2, then we can say that there will be 2 bit shifting at a time. So what does 2 bit shifting means? Okay, let's say we have a block like this, and we have a messages like 1, 0. So at time t equal to 0, this is our message bit. And now when time t becomes t1, this 0, it will go to this position, and this 1, it will come this position. And it will become 1, 0. Now, as we are saying that small k equal to 2, that means 2 bit will shift at a time. Then for the next time, this 0, it will go to this position, and this 1, it will come to this position. That means 2 bits are shifting at a time. And for the next time cycle, this 0 and 1 that we are having here, it will again move to this position, and 1 will move to this position. That means the shifting here, it is happening 2 bits per time, right? That is 2 bits will shift at a time. Similarly, there can be k equal to 3, then there will be 3 bits shift at a time. This is the significance of this small k value. That means how many bits will shift at a time. Now let's talk about the large k value. That means here, this k value. So this large k, it represents the stage, or you can say step, or you can say how many stages are there. Okay. So now if we have a block like this, okay, and if we already know the k equal to 2, that means there are 2 bit shift at a time, small k, then if our message bit is 1, 0, then this 0 will come this position first, and this 1 will come in this position. So this is a k equal to 2 case, right? That means 2 bit will shift at a time. That means in the next time, this 2 bit that we are here in this 2 first block, it will move to this position and this position. And in the next cycle, what will happen? This block, this bit will go here, and this bit will go here. So what is the significance of large k here? The significance is that this k represents how many stage or step it is taking. That means whenever this 1, 0, it is coming here, that means it is stage 1. That means it is filling the stage 1 or step 1. Then in the next stage, it is going to fill next 2 block, right? So you can say this is our stage 2. And for the third case, it is filling this 2 position. Then this is, we are calling stage 3. So this large k value, it represents how many stages are there. So there are 3 stages. So if I have a k equal to 1 and block like this, that is small k equal to 1 means 1 bit shift at a time. So the bit, it will come here, first bit, then it will go to the next cycle, it will go to the next bit, the next position, and for the next time cycle, it will go to the another bit. That means there will be 3 stages, right? So in this case, the large K is 3 and small k is 1. So 1 bit shift at a time, and how many stages are there? These two represent these two things. Now here K into K, it will give us total number of shift register that we need here. Okay. So if I talk about this case, where our small k is 2 and large K is 3. So if I multiply this small k with large K, that means 2 into 3, we can say that there will be 6. That means total 6 stage shift register will be requiring here. And for the second case, here the K multiplied by large K, it will give 1 into 3. That means 3 shift register will require there. 1, 2, 3 shift register, and in this case 1, 2, 3, 4, 5, 6. Total 6 shift register will require. So the thing is that K into K, this will give us what? The total number of shift register. Okay. Then let's talk about this n modulo 2 adders. So n modulo 2 adder means we are getting code word, right? We are giving the input sequence m, and we are getting some code word sequence u. So this code word sequence, it consists of certain amount of bits. So here n modulo 2 adder means n number of bit is present in the code word. So what is meant by that? Let's say we have m is equal to 1, 0, 1. Okay. So what we'll do, we'll just insert this message bit one by one to our module, to our encoder. So whenever we'll give this 1, certainly we'll get some of the code word sequence here. And this code word sequence, based on the n modulo 2 adders, it will determine the code word sequence bit. So this will be clearer in the next slide. If I go to the next slide, this will be more clearer. But for now, what you will just remember that for a n modulo 2 adders, the number of code word sequence bit, it will be n bit. Let's say if we have n modulo 2 adders, that is n number of modulo 2 adders, the code word sequence will have n number of bit. Okay. So here you can see there are 3 bit, 3 modulo 2, n number of modulo 2 adders. So 1 to n. So there will be code word sequence u, where there will be n number of bit. Okay. So let's give an example here. Let's say if I have 1, 1, 0 here. So you can see that this modulo 2 adder, it is connected with some connection here, right? So this is our 1 connection, 2 connection, 3 connection. So what will be the output here? If I connect this and add this 1 plus 1, it will give 1. 1 plus 1, it will give 0, and 0 plus 0, it will give 0. Okay. Then for the second case, for this number 2 modulo 2 adder, this one, and this one is connected. That means same thing will happen. 1 plus 1 plus 0. So it will give 0 here. And for the n number, for this n number, okay, for this n number, that means for this last one, these 2 will be added. That is 1 plus 0, it will give us 1. Okay. So this 0, 0, 1, this is our code word sequence. Let's say U1. So in this U1, we are having 3 bit, right? That means n modulo 2 adder will give us n number of bit. So if I have 3 modulo 2 adder, we'll get 3 bit at our code word. Okay, so I think it will be clearer in the next slides or next pages. Okay, so now after that, the fourth thing is our code word sequence, which is represented here, u equal to u1, u2 up to uy. So this is the desired code word that we want to get after the convolutional encoding. Okay, so now let's see a convolutional encoder example. So this is our convolutional encoder where the rate is given as half and k equal to 3. So we have to understand first what is this rate and indicates. Okay, so the rate means nothing but k by n. So what is k? K is, we already know the small k, number of shift, number of how many bits will shift at a time. This represents this k. So here k equal to 1 means 1 bit will shift at a time. And then the n is what? K by n, right? So n will be 2. So n is 2 means what? 2 means n equal to 2 means what? It means that there will be 2 modulo 2 adder required. That means there will be 2 modulo 2 adder required for this case. So rate half, if it's given as rate half, then it will indicate that the small k is equal to 1, that means 1 bit shift at a time, and n equal to 2, that means there will be 2 modulo 2 adder will be required here. And the large k, 3, it is nothing but there will be 3 stages or 3 steps. That means 3 stages will be in total. So as we have said previously, the k multiplied with k, it will give how many register, shift register will be required. So here small k is 1 and large k is 3. So we can say that there will be 3 shift register we need here. Okay, the number of shift register will be 3. Another thing is that sometimes there will be convolutional encoder, there will be given like 2,1 encoder. So what is this 2,1 represents? First 2 represents the n value and second one represents the k value. So if it is given the rate or like this way representation, then you will understand that if it is given in 2,1, then first one will represent n and second one will represent k. And if it is given rate, then it will be k by n. Okay. Okay, so now from this rate given, we can say that the number of shift register will require here is 3, right? So there will be 3 shift register that we need. So let's draw first. There will be 3 shift register, 1, 2, 3. And another thing that we will require is the connection diagram. So what is this connection diagram? This connection diagram represents that how many to this block, how the modulo 2 adders are connected. So here we will say, we have already said that n equal to 2, right? That means there will be 2 modulo 2 adder. So let's draw it, 1 modulo 2 adder, 2 modulo 2 adder. And from the connection diagram, it is G1 is 1, 1, 1, which represents that this modulo 2 adder will be connected with all the block 1, 1, 1. Then similar goes for the 1, 0, 1. It will be connected like 1. Then second block, it will not connected as it is given 0. And the third block, it will be again connected to 1. Okay. And then if I take the output from here and take another output from here, then we'll get a code word sequence U1 and code word sequence U2 from these 2 positions. And the input bit, I will give it from this position. I will give supply or insert the input bit. So now to understand the whole process, let's go to the next slide and we will see how this thing works. Okay, so this m equal to 101, this is our message bit that we want to send to the convolutional encoder. So this is our encoder, and after encoding, we'll get a code word sequence U.